In this video, I'm going to show you how to convert degrees into radians. So here we want to convert 210 degrees into the equivalent measure in radians. So before we get into this, let's back up and think, what do we know about the relationship between degrees and radians? Well, we know that 180 degrees is equal to pi radians. That just comes from the unit circle, so it should be really familiar to us by now. So what if we want to figure out what 1 degree is in radians? Well, we can start out with this formula here, 180 degrees equals pi radians, and why don't we just go ahead and divide both sides by 180. So 180 degrees divided by 180, that just gives us 1 degree, because 180 over 180 is just 1. And then on the right hand side, we've just got pi over 180 radians. Okay, here we go. So this is really important. This is going to be our kind of conversion factor here. Every degree is worth pi over 180 radians. So if we've got 210 of those degrees, how much is that in radians? Well, we can just think about multiplying both sides of this equation by 210. So times 210 times 210. And then on the left-hand side, we've got 210 degrees. And then on the right-hand side, let's just write this for now as pi over 180 times 210 in radians. So now it just remains to simplify this fraction multiplication. So let's go ahead and simplify that over here. Pi over 180 times 210. One thing that jumps out at us is 210 and 180, these both end in 0. So we can think about dividing by 10 here and here. Those zeros will cancel out. And then we've just got pi over 18 times 21. That's a lot easier to think about. These are both divisible by 3. 21 divided by 3 is just 7, and 18 divided by 3 is just 6. So we've got pi over 6 times 7. Is there anything else we can simplify? No, it doesn't really look like it. So let's just go ahead and multiply. We get 7 pi over 6. And there we go. That's as far as we can simplify. So that's our final answer. 7 pi over 6 radians is the equivalent measure for 210 degrees. Alright, so now that we've done an example, we can come up with a general process for converting degrees into radians. And that goes like this. For any angle theta given in degrees, the equivalent measure in radians is given by theta times that conversion factor that we found earlier. That was pi over 180. That's how many radians are in a single degree. Then multiply that by theta to get the radians in the full theta degrees. So there we go. That's the way we convert from degrees to radians. We just multiply by pi over 180. Great, so now that we've got a strategy in place, let's go ahead and do some more examples. Let's convert 40 degrees to the equivalent measure in radians. And remember, all you have to do is start out with that degree amount, 40, and then multiply it by pi over 180. That's what we discovered on the previous slide. And then all we have to do is simplify this. So we'll notice that these are both divisible by 10. 40 divided by 10 is just 4, and then 180 divided by 10 is just 18. So this is 4 times pi over 18 simplified. Can we simplify it more? Well, 4 and 18 are both even. So 4 divided by 2 is 2. 18 divided by 2 is 9. So we've got 2 times pi over 9. And it doesn't look like we can simplify it anymore, so that'll be our final result, 2 pi over 9. That's how many radians makes up 40 degrees. Okay, next problem, convert 215 degrees to the equivalent measure in radians. This is going to be the same process as before. We're just going to take that number, 215 degrees, and multiply it by the conversion factor. Multiply it by pi over 180, and then we just have to simplify it a bit. There's not a 0 in this number anymore, but there's a 5, so we could divide both 215 and 180 by 5. That's one possibility. I think an easier way, though, would just be to start out by doubling both numbers. Then we'll introduce a 0 there. So let's go ahead and double 215, and we get 430, and then times pi over double 180, and you get 360. And now we've got an equivalent expression here, but now we've got zeros here. We can cancel those zeros, divide top and bottom by 10, and we've just got 43 times pi over 36. And is there anything else we can simplify here? 43, actually, that's a prime number, so it doesn't look like anything else can be simplified, so that's just our final result. 43 pi over 36. Here's our final example. We want to convert negative 70 degrees to the equivalent measure in radians. And okay, so this looks a bit intimidating because it's a negative degree measure. It's a negative angle, but really the process is just the same. We take that angle measure, negative 70 degrees, so negative 70, and then we multiply by that conversion factor. So times pi over 180, and then we just have to simplify. So let's go ahead and simplify. We can divide 70 and 180 by 10. So cancel out those zeros, and we've just got negative 7 times pi over 18. Can we simplify anything else? Doesn't really look like it. 7's prime, so then 18's not divisible by it. So nope. We've just got negative 7 pi over 18, and that is our final result. Great, so now we know how to convert an angle measure in degrees to its equivalent measure in radians. And in the future, we'll also learn how to perform the opposite conversion, radians to degrees.